Okay, this tutorial here is 5.7, solving quadratic equations again, and this time using completing the square method. What we'll look at here is when you have to use completing the square, you have to look at a situation where if you look at the trinomial, you know that you can't get two numbers that multiply out to 7, negative 7, pardon me, and add to 4 that easily without making fractions or something like that. So it doesn't lend itself to the first method very well. So what you do is you complete the square. So how you complete the square is you think of taking this number and moving it over here and just leaving the x squared and x itself on the left side. So what you do is you do that first. And then you complete the square on the left side, making a perfect squared term on the left side. So if you want to make a complete trinomial that will come out into a perfect squared binomial on that side, what you always do is you take half of the x term and square it. And then add it to both sides. So half of 4x is 2, and 2 squared is 4. So I'm going to add 4 to both sides. So I'm taking half of the x term, which is 2, and 2 squared is 4. Okay, so that would give us this. Now this then becomes x plus 2 all squared on the left side. And then we have 11 on the right side because we have to add 4 to that side as well. So this now we can go back to what we did in the last tutorial and use the square root property to solve. So now we can root both sides. X plus 2 is going to equal plus or minus the root 11. Okay, remember you have to have that plus or minus in there. So then bring the 2 over to the other side. So x is going to equal plus or minus root 11, subtract 2. That's our answer. So if you wanted to write it out as its two answers, minus root 11 minus 2 and plus root 11 minus 2. Okay, so that's our first example. In our second example here, we're going to look at this one here. So if I were to do the same thing, x squared minus 8x equals negative 51, then I take half of this, which would be negative 4. Negative 4 squared is 16. Added 16 to both sides. So this is going to give us x minus 4 all squared is equal to negative, and this turns out to be a negative number here. So that's going to negative 35 here, pardon me. So that's going to be impossible to do because you cannot square root negative numbers, so there's no solution set. Because you can't square root the negative 35. Sometimes that does happen. Okay, now there is another example, a couple other examples of how to complete the square here, and I'm going to move this up, make sure it's still in the field of view. Okay, so in this example here, when we have numbers that are not simply x squared, we can't actually do decomposition here for this one. It has to multiply to negative 35 and add to 30x. So you can't really decompose that one. So what we have to do is we have to use completing the square. And what we have to do first of all is isolate the number again. So isolate the number on itself. So take 5x squared plus 30x here by itself and equal it to 7. Once you get to that point, you now are going to be completing the square again. But you're going to have to remove this 5 first. So remove the 5 by dividing 5 out on all the way across here. Okay? So if I divide 5 out, so this would be x squared plus 6x is going to equal 7 over 5. Okay, I do it for everything. So now I can complete the square on the left side again. Half of 6x is 3. 3 squared is 9. So I'm going to add 9 to both square sides. Now, we still have this 7/5, so you have to be careful when you're adding fractions with mixed numbers. So this is going to be x plus 3 all squared on this side. And we're going to add, how many fifths are in 9? Well, there's 45 fifths in 9, right? So 45 plus 7 is going to give us 52 fifths. Remember, 9 is like 45 over 5. And recall that. And then when you add 7 to it, it's just 52. Okay, so we're going to end up getting a bit of a interesting one when we root both sides. Okay, so if we root both sides now, we get x plus 3 is going to equal plus or minus the root of 52 over 5. So we have to rationalize that. X plus 3 is going to equal plus or minus, it's root 52 over root 5, so it's root 50. How you rationalize that, if you're thinking of it, we could work out, do common prime factors here. 52 is just 2 times 13. And this one here on the bottom is just root 5. Or sorry, 5. So if I want to get rid of the 5, I have to multiply by 5s like that. So then this would then become x plus 3 is equal to plus or minus. So we can take out a 2 on the top here because I'm taking the square root. 2 root 5 times 13 is going to give us what's under the root sign there. So 5 times 13, if we work that out, is equal to 65. And then what's on the bottom here, we can take the 5 out here. Okay? So I'm running out of space there. I'm going to have to flip the page here. Okay, I have another example there, but I'm going to just finish this one off first. So this is going to be, we'll do this one next tutorial. X plus 3. And this is equal to plus or minus 2/5 root 65. So all we have to do is subtract 3 from both sides. So x is equal to plus or minus 2 root 65 over 5 minus 3. So there's our answer for that question. Okay, now I don't quite have enough time to do the other completing the square, so I'm going to do that in the next tutorial.